basically we said capacitors, they are components and devices that stores what? Electric charges. The capacitor is made up of two parallel plates. Capacitor is made up of what? Two parallel plates lying side by side. So the parallel plates, they are what? They are parallel. They are lined what? Side by side with a dielectric. So basically, let's say this is our capacitor. This is our capacitor. This is our first plate. This is our second plate. Now you can see something at the middle here. There is a distance between the two plates. There is a space between the two plates. Now, what is that space? This space here contains what we call the insulator or an insulating material. Now, what is an insulator? From our basic physics, we know that insulators are those materials that doesn't conduct. So anything that doesn't conduct is a what? Is an insulator. Now, in this case, this insulator serves as our dielectric. In other words, your insulator is your dielectric. Are we together? Let's call this what? Plate 1, and let's call this what? Plate 2. Now take note, take this down. The capacitance of a capacitor is stored in the area of both plates. The capacitance of a capacitor is stored on the area of both plates. So meaning in this area here, in this plate here, there is a what? A capacitance here. On this other plate, there is a what? There is a capacitance here also. So if you are asked, where is your capacitor stored in the capacitor? We know that capacitor stores what? Charges. Are we together? Now, I'm telling you that the capacitor on the area of both plates, there is a what? A capacitance. Meaning, in both plates, the capacitance is stored on the area of both plates. Are we together? From elementary physics, when we talk about capacitor, there is a general equation that we know from our elementary physics. And what is that equation? The equation is basically what? Q is equal to what? CV. Now, what should come to your mind is what is Q in the equation? What is C in that equation? And what is V in the equation? Now, your Q basically stands for what? Quantity of what? Charge. Quantity of charge. Or basically, you can say your Q is equal to what? Your charge. Now, your C here stands for what? Capacitance. Kappa what? Citance. And the V stands for what? Voltage. Now, the next thing that should come to your mind is when we are talking about these parameters, what are their units? What are their units? Every parameter has a unit except the parameter is a what? A constant. Are we together? So the first one we have here is quantity of charge. And we know that from elementary physics, quantity of charge is measured in what? In coulombs. The second one is what? Capacitance. And we know that capacitance, what's the unit of capacitance? Capacitance is measured in what? Farad. The next one we have here is what? Voltage. Nobody will tell you that the quantity, the unit of voltage is what? Volt. So voltage is basically measured in what? In volt. So basically, what are the units? We have what? Quantity of charge to be in what? Coulombs. Capacitance to be in what? Farad. Voltage to be in what? Volt. Are we together? Now let's call this what? Equation 1. From elementary physics 2, we know that when we are talking about quantity of charge is also equivalent to what? 1 ampere second. So Q, which is quantity of charge, and quantity of what is quantity of charge? No, quantity of charge is 1 coulombs is equal to what? 1 ampere second. From what we have here, you can see that we are using the units to represent this. We are using what? The unit to represent. Now let's use their parameters. Let's use the parameters to represent what we have here. We know that what is measured in coulombs. We know that quantity of charge is measured in what? Coulombs. What is measured in ampere? We are talking about what? Current. And when we talk about seconds, we are talking about what? Time. Note, there are other units of what? Time. There are other units of time. But the one we know, the one we recognize, which is the SI what? The unit, SI unit of time is what? Seconds. So basically what we have here is Q is equal to IT. We know Q, what's the unit of Q? Coulombs. What's the unit of current? Ampere. And what's the unit of what? Seconds is time. So basically, quantity of charge is also equivalent to what? 1 ampere second. Are we together? So let's call this what? Equation 2. Why are we noting equation 1 and equation 2? Why are we doing this? We are doing this so we know the numbers of equations we've generated as this course is concerned. From equation 1, we are calculating for what? Quantity of charge. Equation 2, we are also calculating for what? Quantity of charge. But quantity of charge, in calculating for quantity of charge, we know that we have what? Two basic equations. The first one is what? Capacitor and what? Voltage. The second one is what? Current and what? Time. What if you are now asked to calculate for capacitance? Capacitance. Now they are asking you to calculate for C. Where should you go to? You come to equation 1. You make what? Your C the subject of formula. Now from equation 1, from equation 1, we know that what? Q is equal to what? CV. Our interest is to what? To know what our capacitor is. To know what our capacitance equation is. Now, getting your capacitance equation, what do? You divide voltage to each side. So you are dividing voltage A and you are dividing voltage A. So basically, your capacitance is equal to what? Quantity of charge over what? Voltage. Are we together? So we now have what? Our first equation. We have our first equation. We have our second equation. And this is our what? Our third equation. Are we together? Now, looking at our equation, if you are asked in your equation 3, what do you think you can do to increase the quantity of charge in this equation? We know that what? Capacitance is equal to what? Quantity of charge per what? Per voltage. Are we together? Now, they're not asking you, look at your equation 3. What do you think you can do to this equation to increase your quantity of charge? Meaning, what do you increase in these parameters to affect your quantity of charge to be increased? Are we together? Now, somebody will say capacitance. If you affect capacitance, you are actually what? Increasing the what? The quantity of charge. That is very wrong. That is very, very wrong. Now, the only way you can increase your quantity of charge is when you increase voltage. If you increase voltage, you are basically what? You are increasing your what? Your quantity of charge. Basically, you are affecting your what? Your charge. But if you are increasing your capacitance, which cannot be, your capacitance, the only way you can increase your capacitance is when you are giving the value of your capacitor. Are we together? In essence, basically, if you increase V, you are equally increasing what? Your quantity of charge. If they say V, if you increase V, you are actually increasing C. If they ask you, is this statement correct? This statement is not correct. But if you have something like this, V, if you increase V, then this is not equal to this. Basically, you are not increasing this. You are not increasing this. I told you earlier that the only way you can increase this is when they give you two capacitors and they tell you this capacitor is lesser than this, or this capacitor is what? Is greater than the other capacitor. But you cannot increase the capacitance. The capacitance tells you the value of your capacitor. The capacitance is based on the construction of the capacitor. Are we together? So basically, if you increase voltage, you are equally increasing what? Quantity of charge. Which this statement is what? Both correct. Are we together? Or vice versa, if you increase Q, you are basically what? Increasing what? V. Are we together? Now, what if they give you some capacitance? They give you some capacitance subscript and they tell you to give the standard representation of this capacitance. What are you to do? So you have something like 1 MF, we have something like 1 UF, we have something like 1 NF, then we have something like 1 PF. What are you going to do? If you have something like this and they are telling you to represent this, give the standard representation of this capacitor. What are you to do? The standard representation of these capacitors are what? The first one is what? Millifarad. Millifarad. So we have 1 times 10 raised to the power of what? Minus 3 farad. The next one is 1 microfarad. And 1 microfarad is equivalent to 1 times 10 raised to the power of minus 6 farad. Now, if you have the next one, which is what? 1 nanofarad. What is 1 nanofarad? 1 nanofarad is equivalent to what? 1 times 10 raised to the power of what? Minus 9 farad. Now the last one is what? 1 picofarad. Now if you know the standard representation of 1 picofarad, just drop it on the comment section. Thank you. Now, if you have this four capacitance value, and these capacitance are giving you the standard representation. If you have this four capacitance value and they're asking you which of these capacitors is effective, which of these four capacitors is what? Effective. Now, what should come to your mind is when you have two capacitors, capacitor that has greater value and the capacitor that has what? Lower value. You should note that what? The capacitor with lower value is more effective than the capacitor with what? Higher value. So basically we have four capacitors. We have 1 millifarad, we have 1 microfarad, we have 1 nanofarad, and we have what? 1 picofarad. Now 1 picofarad is basically 1 times 10 raised to the power of what? Minus 12 farad. Now note this. All these values of farads are what? Has a sequence of what? 3. Whether what? Increasing or decreasing. They have a sequence value of what? 3. Whether increasing or what? Decreasing. What do I mean? If you add 3 to this, what will you have? 6. If you add 3 to 6, what will you have? 9. If you add 3 to 9, what will you have? 12. So they are what? Are they increasing or decreasing? They are basically what? Decreasing. We have minus 3, minus 6, minus 9, and minus 12. So basically the lowest capacitor here is what? The picofarad. And we said earlier that those capacitors with lower value are more what? Efficient. So your capacitor that is efficient in these four capacitors is what? Is your what? 1 picofarad. So this is what? More effective. This is more effective because it is what? It is the lower capacitor in this aspect, and it has what? Lower value. You can agree with me that minus 2 is greater than what? Minus 3. But here we have minus 3 and minus what? And minus 12. So minus 12 is lower than what? Minus 3.